Just two items here. One, thank you for everybody who filled out the midterm course evaluations. Those are helpful. We got about a 50% response rate, which is typical. Though nobody identified any glaring issues, there were two concerns, I would say. One of them was pace, and the other was what I'm just calling community. The first one is pace. That there was a fear that that it might get, even though it's an honors course, it might get a little bit too unwieldy. Or that I'd say that if you've been doing well up till now with the pace and with getting in the routine, you'll probably be fine going forward. I say that the pace is going to increase a little bit simply because material builds on itself, right? There's no way that you can even talk about arrays unless you have a solid foundation in like loops, for example. There's no way that you can talk about loops unless you have a solid foundation in what variables are, right? So this material builds on each other, and that's what I mean by the pace getting quicker, in that we'll assume that you have a good grasp on this prior material. And if you don't have a good grasp on it, or you feel that you're kind of weak in it, that's fine. Go back. Watch some of the pre-prepared videos if you didn't do it the first time. Read the book chapters there. Do some extra exercises on that particular thing. If you think, well, I wasn't really getting for loops for whatever reason, go back and supplement whatever you were doing. So that's my advice on the pace. The second, community. What I mean by that is, it was several people, this is 2 or 3 people identified that it's kind of more difficult to get engaged with other students, and believe me, that this is not uncommon. Every honors course that I've had, this has been, I don't know if it's been an issue, it's just been the nature of an honors course. Honors students like yourselves are far more reticent, right? Less, like hardly anybody talks in here, for example. When I come in, the other class is all, conversation back and forth, back and forth. That can be a good thing, that can be a bad thing, right? There is a social aspect to this. Not that they're disruptive. I'm not saying that they're disruptive at all. I'm just saying that there's a lot more talk back and forth. People are making those connections and creating friendships, or at least school friendships or whatever. My advice on that is, you don't have to just keep your circle as the honors circle, right? You can branch out and you can talk to the folks in the main section. You can even bounce ideas back and forth, because all the C stuff that you're doing, they're doing as well. So if you have a question on C, or maybe they have a question on C, and you've got like a completely solid background from this course, be an unofficial tutor to somebody over there. I don't know how many people are in the learning community, the official learning community, which is in, I want to say Shram, maybe? Anybody? No? Okay, so is what's the honors dorm? Nyhart? No? Okay. I don't know where anybody is then. But start, even if you're not in one of those official communities, you can start establishing your own community. Another piece of advice for that is branch out beyond your own classes. For example, you can get involved with CSAB. CSAB is the School of Computing Student Advisory Board, the SAB, Student Advisory Board. If you're not on the Discord already, you should get on there, because there's a lot of valuable information, crosstalk with other students, upperclassmen, announcements and stuff like that. It's like getting it's a Discord for that bits and bytes, but it's run by the CSAB group. If you want to become an officer in it, you can run. If you just want to be involved in some way, that's another way that I would highly recommend that you get involved there. So hopefully you're talking about this kind of stuff in like CS10. Yes? No? Maybe a little bit? Okay. So whatever advice they're giving, take that advice too. But otherwise, again, thank you for the midterm course evaluations. Those are the only two commonalities that I saw in the feedback. And then the other other item that I wanted to bring to your attention is priority registration opens on October 24th. As freshmen, you probably won't be able to register until the next week. I don't know. Don't worry about it as far as the core CS courses are concerned, because there's plenty of room. Now, if you're going to continue with the honors track, what you're going to want is Computer CSCE 156H. That's Computer Science 2. right? It's a continuation of this course. I am the instructor for that currently. CSCE 235H, which is discrete math. That's the honors version as well. There are non-honors versions of both of these if you want to, get off the honors track, but everybody's doing very well in here. I'd encourage you to continue. I'm not the instructor for 235H. And then typically what you do is you also take this online Unix course. It's just Unix programming, Bash scripting, maybe some PowerShell scripting, I'm not sure. But it's all online. It's 1 credit hour. Yeah.
Can you describe what we do in like 156H and 255H? Like, because like there's the course descriptions, but like
Sure.
what we actually do.
So for Computer Science 2, we start, so for the, I'm going to speak about the honors version. We start out with the first 3 weeks with a third programming language just to get up to pace, because in the main section, we start with Java because they don't have Java necessarily yet. So assuming that you're coming from an honors section where you've got Java and C, we do PHP, third programming language. And so we just cover that for the first 3 weeks. Then we get into, that's the first 3 weeks there. Then we get into object-oriented programming for 3 weeks in Java. So we're covering Java in here, but we're not covering the hardcore object-oriented programming aspects of Java. And so we'll do that there. Then we get into databases, database design, database implementation using SQL. That's a structured query language. And then database connectivity using Java, programmatically connecting to the database that you build. And then data structures and algorithms for the last 5 weeks or so. Throughout the semester, what you're doing is you're building this iterative project. And so you have phases of this project. The first phase is you create your classes, and then you do some EDI, electronic data interchange. Then the next phase, you use those classes and implement some object-oriented programming inheritance stuff. You use those classes to design your database, implement your database. Then you connect to that database and populate stuff. So basically, you have it's project-based. Instead of hacks and labs each week, you have labs each week. But all of your assignments are every 2 weeks or so, and it's this project that you're building on top of each time. So that's the basic structure of the course. 235, I can't speak to that because I'm not the instructor, but typically if I were the instructor, that's, well, the content itself is invariant. It's discrete math. So all the math that you've been doing up to this point is continuous in calc. Right? You're looking at continuous domains where you can infinitely divide things. A discrete domain is not that way. A discrete domain is countable domains, finite domains. So you look at things like proofs, proof techniques, logic, predicate logic. Then you get into sets, set theory, graphs, graph theory, various things like that. And so it's way more mathematical. Probably depends on the instructor. If it were me, there'd be a hell of a lot of programming. But if other instructors don't generally do a lot of programming in it because it's all written, written proofs, stuff like that. So, and then this one is just the 1 credit hour Unix stuff. So hopefully that helps. Now I will say that the difference between the H section and the regular section are, I'd say in this class there's maybe 50% more work than the regular section because we're doing 2 languages at once. It's not going to be that much in 156H, maybe 20% more. In fact, I can quantify that, 20% more work definitively, because the way that the honor section will work is that every assignment has about 10 or 20% extra credit, and for the regular section, that's extra credit. For the honor section, it's required credit. So you're doing a little bit extra on each phase of that project. Right? But otherwise, you're doing the exact same project. I'm not making 2 projects.
Thank you.
Uh-huh. And then 235H, I can't speak to that at all. That's when you join the Discord and you ask other students for their opinions. Right? Keep in mind that it is a public Discord. I'm on it. Anybody can be on it. So, you can be identified through your Discord pretty easily. So be careful. Nobody's going to care. I can almost guarantee you that there are probably only 2 other faculty on that entire... I can almost guarantee that there are 2 other faculty that know what the hell Discord is. So, any other questions?
Is there I'm going to major in computer engineering. Is there like a difference for like computer engineers as far as...
Not in the first 2 years, not in the first, so talk to your advisor to be sure. I don't think that you take 230 and 231 in the first year, but you may not. That's when it starts to diverge because 230, computer engineers take 230. This is a hardware now, a hardware architecture. 230, and then computer science and software engineers take the 231. But as far as those courses that I just mentioned goes, they're all the same. Yep. Any other questions? And then, of course, EE stuff. I don't know in the first year.
I don't know. I'd have to talk to my advisor.
Okay. All right. Yeah, and it's also different. Yeah, I don't know. I don't want to give you bad information. But to review what we were doing last time, we started looking at multidimensional arrays, and I kind of drew it up here on the whiteboard here. But now I've pulled out the actual slides that are on the pre-prepared videos here. This is what it looks like, right? If you want a 2-dimensional array in C, then you need 2 stars, right? 3 dimensions would be 3 stars, 4 stars, 5 stars. Don't do that, right? 2 stars is enough. This one is, we're going to create a 10 by 10 matrix, right? So what we do is we call malloc to set up that initial array of pointers so that each one of those pointers points to an array of 10 items. We do that in a loop here. So to walk through that, again, on line 2, we set up the initial matrix pointer. On line 3, we're setting up an array of pointers. Each one of those pointers is going to point to a row that gives you 10 integers. Right? So in the for loop, you set up the first row. Then on the second iteration, the second row, the third row, etc. Right? Now, if you need to clean up after yourself, right, the code that we developed for that was to free stuff up. But we didn't just free up the table here. Right? We did that at the end. Because if we freed up the table, this thing over here would end up getting freed up. But what about all 100 of these integers over here? They'd be lost. It would be a memory leak. So when you go to free something up, you just reverse it, right? You delete all of the rows, so you need a for loop, and then you can delete that column of pointers. And that's what this did here. You don't need to go backwards, right? You can go forwards. I just had to reverse the animation. That's why I went backwards. But we're going to free the ith row in any order. Right? Once you've freed each row, then you can free the table. Okay? All right, so what we're going to continue on today is using arrays and functions, right? In C. Let's go ahead and go with C first, right? When you pass an array to a function, you need to pass its pointer. So in other words, you're passing in int star array. Right? When you do that, it looks kind of like you're passing in a regular old integer pointer, like you're doing right now in your in this hack, right? You're passing in an RGB value by reference so that you can change that. In that context, that pointer is only referring to one integer. By implication, what you do is when you do this, you need to also pass in the size of the array, right? This is basic bookkeeping. So it's going to look exactly the same way that we've been passing pointers before, but by implication, by putting this other parameter that is the size of the array, we're saying, no, this isn't just one integer. This is n integers, 5 integers, 6 integers, 7 integers, or whatever, right? So let's go ahead and look at an example here. Get rid of this. Increase the size here. Right? So let's go ahead and create a function here that takes an array of integers and adds them all up. Right? That's very, very basic. So what I'll do is I'll call this sum. Right? Right? A sum of integers is going to return what? An integer. Right? Int sum. Okay? Now, to take this array, it's just simply int star array. Now, if I left it at that, you wouldn't be able to tell how big this array is, would you? Right? And by implication, that when we're saying that this is only one integer, right? But by passing in another parameter here, int size of array, or size, or just simply n is usually what we use, right? N is an appropriate variable name when you're in the context of talking about the size of an array in C. Right? So generally, like, yes, this is more descriptive, size of array, right? But we'll go ahead and keep it simple and go n here, okay? Now that we know both of these things, we have the array and we have its size, we can go ahead and create int total, there we go. And then for int I equals 0, I is less than n, I plus plus, an idiomatic for loop here. Run over each element and add it to the total, array sub I, and then return the total. Now tell me, there is a mistake here. What's the mistake? So suppose I had 10, 20, 30, 40, 50 in that array. What am I adding 10 to? I'm adding it to the total. What's stored in that total as of line 8? Default values in C, are they defined? Nope. So make sure that you always initialize something. There we go. And return the total. Let's come down here and make sure that it works. To do that, I'm just going to create an array here. The one that we've been using so far is the primes array. Tell me what the first, 8 primes is. 2, 3, 5, 7. It's 4, 5, 6, 7, 8. Is that all of them? First 8 primes? Okay. So let's go ahead and create a total, right? And we'll call this sum function here. And we'll sum up all of the primes. And there are 8 of them. Right? Printf, sum of first 8 primes is %d and the line. Right? And total. GCC demo. Does anybody know what the sum of the first 8 primes is? Looks like 87, but do we know? Yeah, go ahead.
It's 23, so
Oh, thank you.
actually it's 19.
Oh, there we go. I button mashed too, sorry. All right. I thought 87 looked right. 77. Is that right? Can somebody do that in their head really quick? Or I'll just use Wolfram Alpha. Somebody pointed out that Wolfram Alpha was actually used in the movie Arrival. Right, in the background screens, you can see that there's a Wolfram Alpha code being run, and it's the actual code that was written. So first, or sum of first 8 primes. Right? I thought that was interesting. 77. There we go. So you didn't have to do it. Great. It works. So now observe here, right? What I did was I passed in an array. How do we pass in an array? By reference, right? An array is a chunk of memory. When you call malloc, malloc gives you a chunk of memory. How does it do it? With a pointer to the start of that memory. And that's how we're treating it here, right? Now, you also need to know that there are 5 elements in here. And that's where the second one comes in, int n. Without that, you don't know how many there are. If I didn't have this here, there's no way that I could write this loop at all. Right? Again, there is no way to tell how big an array is once it's been created. Do not believe any crappy blog post that says otherwise. Right? You have to do this. Okay? So, total. What if I did something like this, though? Array sub I is equal to -1. So what am I doing there? I'm the function now. You gave me your array, and I go through and I sum it up because that's what you wanted. By the way, here's 77, right? But at the same time, I'm going and I'm messing your stuff up, right? I'm able to do that because this is passed by reference. Let's see the effect of that down here. For int I equals 0, I is less than n, I plus plus, printf, array sub %d is equal to %d and the line, and we'll print out the index and primes sub I. So when I print this out, what are the contents of that array going to be? Remember the consequences of pass by reference. The swap, right? The first swap function that we wrote, it didn't work because it was passed by value. Copies were given to it. But we changed that so it would work by passing by reference. Pointers to the buckets over there. So if with a pointer, we're able to make changes to the variable in the function. That has consequences, right? There we go. All of our data has been erased, right? Does that sound like a good design? Nope. I just asked you to sum this stuff up. I didn't say that I want you to sum this stuff up and screw it all up for me, right? So what I'm going to do is I'm going to introduce a new keyword here. It's not a new keyword, but it is a keyword used in the context of a function and a pointer. Const. Const is short for constant. What do you think the effect is of adding it to a parameter like this? Can't change it, right? Exactly. Oops. Come on. Kill that. It won't even compile now, right? Assignment of a read-only location here on line 11. It's saying that, wait a second, you said that you promised that you weren't going to make changes to this because it's constant. You can't change it. It's read-only. But you did that on line 11, right? I'm not going to let you compile because that's an error. You broke your promise. Once you get rid of this, then you are keeping your promise, and it will compile, and now changes are not reflected, right? It's preventing, yes, you can make changes because you're passing it by reference, but by placing const in front of that, you're telling the compiler, if changes are made, detect that and refuse to compile, please. Right? So the const keyword can be used to prevent changes to your array. Right? And that's exactly when you should use it. Right? You can use the const keyword to prevent a function from making changes to your array. Now, there are ways around it, right? But I won't show you how to do it. Basically, you can trick the compiler and still make changes, and the compiler can't catch you on it. But then you're going out of your way to circumvent that keyword. Why did you use the keyword to begin with, etc. So it's a design thing. It's not a security thing. It's a design thing. Okay. There is a question here on the scheduler. It shows that 156 is just online. Is that correct? No, it is not. Absolutely not. Sorry. So going back to the 156H next semester, there is a in-person and online section. That's a historic reason from COVID, but we just kept it because why not? There's no difference. There is no attendance required. So even if you plan, and I will continue doing the live stream here, but the online section, I think, costs more. So even if you plan to treat it like an online course, I would still recommend that you register for the in-person section. Don't quote me on it, but I think, ask your advisors, I think that there is an added cost to taking online courses at UNL. Is there not? Is there not? Nobody knows? Okay. So in any case, there's no exams in 156H. There's no exams in 156. So in-person attendance is not graded or required. You can go to the online section. Yeah.
Is there a reason why? Well, I'm in computer engineering, but they're making me take like 3 different computer science classes this next semester.
Well, typically what you take is 156, 235, and 251. Are those the 3 classes?
I don't know. I'd have to look again.
Okay, yeah, that's a typical second semester for computer science and computer engineering. If they're also making you take 231 or 230 in your case for computer engineering, depends on what else you're taking, but that's quite a load there. Yeah.
Is the in-person section for 156 honors locked for like enrollment scheduling? Because I know when we were registering, they sort of somewhere for 155 honors, but it provides you.
Yeah, it's hidden to not just allow anybody to find it. So my plan was, I mean, we've got a couple weeks here still before you can register, but.
Well, I have priority registration, so I register on the 17th.
17th? It said 24th. Oh my. Okay. then I will get that information to you today on Piazza. You just need you don't need a permission code, you just need a course code. I don't know what it is, I'd have to look it up. And then you then put that into the registration system to search for it, then you can register. Anybody with that code can register. So don't share it generally. I can tell you, however, I think they're one right after the other. I don't want my entire calendar on YouTube here, so I'll bring it over here. But in 156 is Monday, Wednesday, Friday. This is the regular section. Monday, Wednesday, Friday, 10:30 to 11:20. And then the 156H is immediately after at 11:30 to 12:20. I have no idea when the labs are. I'd have to look that up. Typically, they're on Wednesdays, though. So they're one right after the other anyway. So scheduling-wise, think 11:30 to 12:20, Monday, Wednesday, Friday. And I'll post all that information on Piazza. Really? Wow. Yeah, priority risk. Okay. Does that answer? Okay. Anyway, back to arrays. Let's see. So you can use the const keyword to prevent a function from making changes to your array, which you should, right? What about returning? You can also create a design functions to return an array. And because arrays in C are nothing more than pointers, right? This makes sense. Malloc does it, right? Why can't we do it? Malloc returns a pointer to a memory location that you can treat as an integer. We could do the same thing. Let's take a look at a really simple example here. What if I wanted, say, I don't know, counting array, get counting array. Now what I mean by that is, let's document it. Oops, whoa. This function returns an array of the given size n that contains integers 1, 2, 3, 4, ... up to and including n. So I just want a function for whatever reason, I don't know why, but a function that creates an array of size n and fills it with 1, 2, 3, 4, 5, 6, and then gives it back to you. Okay? All right. So what am I going to have to take as input here? Well, certainly the size, right? And you want an array of a certain size, you have to tell me how big you want it, n. Okay? But what is the return type going to be here? Is it going to be a single integer? Nope. I need an integer pointer. Right? I'm going to create an array for you over here in memory, and then I need to tell you where it is. It's over here. It's right here. All right? Now here's my first attempt. What if I create int array like this? I haven't even shown this syntax here, except that we have seen this syntax implicitly. If I do something like this, say that n is 4. This is called a VLA, a variable length array. Do not use them, right? For the same reason that we quickly abandon static arrays. They are allocated on the stack. This is allocated on the stack. Where? In the stack frame for counting a get counting array. When that stack frame, when you return from the function, what happens to that stack frame? It gets popped off the top, right? What happened to everything in that stack frame? It gets deleted, right? You are not allowed to do this. You can't do this. Return. If I did it, hopefully the compiler catches this. GCC demo. Yep. Function returns an address of a local variable. You can't do that, right? That local variable is destroyed once you return from the function, right? Remember, function calls function calls function. Stack frame on top of a stack frame on top of a stack frame. Everything in that stack frame is local to that function and gets destroyed when you return from it. A static array cannot be returned. What you need is a dynamic array here. Now remind me, how do we call malloc in this case? First of all, what do I pass to malloc? I want an array of size n. Is that it? Remember what malloc takes? You'll get plenty of practice tomorrow. Right? The size of each thing, right? So remember, malloc you're telling malloc how many bytes you want. If you want n, say n is 5, if you want 5 integers, you need to say that there are 5 integers, each one of them takes 4 bytes, and you use size of to determine how many bytes something takes. You also should typecast the return variable, because malloc, there's only one malloc. It returns a generic void pointer that you cast as the pointer that you want to use. Okay? Now you can return it. Of course, I'm not doing anything with it, am I? Right? Are its contents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Nope. So if the contents are not as what you want, then for int I equals 0, I is less than n, I plus plus. Array sub I is equal to I. Is that correct? Let's find out. So I'm going to steal this code here. And I'm just going to simply reuse n here. Int weird array is equal to, what was it called? Get counting array. I called it counting because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Right? N. And I will print out weird array instead. There we go. Oops. Weird array. Oops. I forgot my star. There we go. 0, 1, 2, 3, 4, 5, 6, 7. Right? Remember, there's a disconnect between the index value and ones. Right? So what should I do here? Not I, but I plus 1. Okay. That looks good. Let's do, with 15 minutes here, let's do a more complicated example. Right? So what I want to do is I want to create a function here to, darn it. I'm gonna do, it doesn't matter. I'll do your lab. I forget what's assigned in the lab. I didn't want to do what's assigned in the lab, but if I end up doing what's assigned in the lab, then so be it, right? What I want to do is I want to have a filter function, right? So this function takes an array of the given size and returns an array of integers of the given size and returns a new array containing only even values from the input array. So for example, suppose that we got the array 3, 7, 5, 4, 6, 7, 9, 2. Right? For input, suppose that's our input. It would return an array containing what? Even numbers, 3, 7, 5, nope, 4, 6, and 2. Right? So do we understand what we want here? You give me an array, I want to filter it out. I only want to pick out the even numbers, put that into a new array, and then give you a new array. Okay? Let's think about the design of this function. Get evens. Get evens. There we go. That's what I'll call it. Or filter evens. Except filter evens, you're filtering them out, right? I'd say filter odds. Filter means that you're getting rid of stuff, right? So give me the evens. Right? So I'm going to take an array, an input array, int star array, and its size, int n. Is there an immediate improvement that I should make here? Am I going to be making changes to your array? Nope. I'm going to create a new array containing copies of all those elements. So I'm going to make the pinky promise here that I'm not going to change your stuff. Right? Okay. All right. What's my return value here? I need to return a new array. How did we do that up here? With a return value of int star. You could put some white space in there. You could take all the white space out. I would not recommend that. You could put the white space there instead. Right? This is what I prefer, but just be consistent about it. The white space doesn't matter, okay? We might have to rethink our design here to get it to work. But before that, let's go ahead and whiteboard this, right? Whiteboard it as in, let's point out the steps that I have to do this, okay? 1, what's the first step I should do? In fact, I'll put it as a to-do, because I have implicitly not been doing it when I should have been doing it this entire time. What's the first thing you do in any function? What's the first thing you're doing in your functions right now for hack? 6. Hopefully. Error handling. Error handling. There we go. There we go. If you're not doing error handling, then you're not passing any of the test cases. Right? That's always the first thing that you do. Right? I'll leave it at that. Right? You can come back and do it. That's not the focus of this exercise right now. So what's the first thing I should do after error handling? Actually, no. You know what? Let's take care of error handling here, because it is a new concept with respect to arrays. What are some bad things that could go wrong here? That there are no evens, right? Yeah, it's not really an error, because then, all right, well, 1, 3, 5, what would I give you back? An empty array. All right, fine. All right. But what could go bad with the actual arguments here, array or n? What's something bad that could happen with ARR? If it's null. Or what's something bad that could happen with a size? Negative? All right. Then I'll return a non-zero error code. Return 1? That's the pattern we've been following up till now, and this is why I chose to actually do error handling here. Can we follow that pattern anymore? Am I returning an integer, a single integer to indicate an error? No. I'm returning a pointer. What's the only pointer that I can return to indicate that something went wrong? What's the only pointer value that malloc returns if something goes wrong? If you ask for 5 million terabytes. It returns what? Null. That's the only thing we can do. Right? Okay. And we can't distinguish between any of these. We would have to redesign this entirely. Right? And I'm not going there. To redesign this entirely, we would have to make sure that the return value is passed by reference, which means that we would have to take a double pointer so that you could set the pointer of the pointer. And I'm not going that deep, right? That's what's that movie? Inception, right? That's 2 levels deep. One more level deep that I want to go, right? Okay, so there's error handling. When you're error handling, in fact, let's put that in the notes, right? When error handling with arrays, and you are returning a pointer, the only pointer you can return in the event of an error is null. Right? So that's what you do. Okay? All right, help me out here. Let's just take that one whiteboard example right there. Right? How would you go about finding all, I mean, you certainly need to iterate over it, right? You need to iterate over it and say, okay, 4 and 6 and 2, those go into the output, right? Write that. Iterate over the array and placing even values into the return array. ... For int I equals 0, I is less than n I plus plus. If array sub I mod 2 is equal to 0, then it's even. Add it to the result. ... Add it to the result array. How? Do I have a result array? No. So 3. Insert 2, right? Create a result array. Int star result is equal to a call to malloc. There we go. And that's eventually what I'm going to return, right? So don't forget your return statement down here. Return the result. Right. The return, the pointer, the generic void pointer from malloc, that should be int star. How big of an array do you want? Well, for the example, it was 1, 2, 3. I want three integers. Is that always going to work? No. So, how big? I guess I needed a step before that, right? This is kind of iterative design, right? You design one thing, you realize, oh no, I need to actually insert something else in there, right? It's okay if you write it like this, or if you whiteboard it without even any code, then what you can do is you can say, okay, well, you know, put a step 2.1 inside there, right? And we need to do this. I want to know, find out how many integers will be in the result. ... How do you do that? Well, exactly what we were doing here, but down here, except that instead of immediately putting them into the result, we need to make a counter, right? So count, plus plus. And of course I need to create that. Int count, initialize it to 0, don't make the same mistake that we made up here with total and not initialize it. Initialize it to 0. Every time you see an even integer, increment the counter. Now I know how big. Count times size of int. There we go. Okay, now I can go back down here, and how do I do that? Well, result sub something is equal to array sub I. So let's look at the example here. When I see 3, I'm not going to put it into the result. When I see 7, I'm not going to put it in the result. When I see 5, I'm not going to put it in the result. When I see 4, I'm going to put it in the result. The problem is 4 is at index 3. In the result, is it going to be at index 3? No, it's going to be at index 0. So what does that tell you about what this question mark has to be? Yet another index. Int index. I'll start it at 0. The first time that I add something to the array, I'll say index is equal to that thing. And then, if I add something to the array, what do I need to do to set myself up for the next time that I put something into the array? Index, oops, plus plus. There we go. Excellent. Let's see if it works. Get evens. I've got that weird array, right? I can go ahead and reuse that. Int result only evens is equal to get evens of the weird array. The weird array is of size n, and now I want to print them out. There we go. For I equals 0 to n of the only evens array here. There we go. GCC. Now I should only expect what? The evens of 1, 2, 3, 4, 5, 6. I'm not going to do it on primes. Why? I will only get one value there, and that's not going to be that useful. But this is going to end up being 1, 2, 3, 4, 5, 6, 7, 8, whatever it was. So I should get 2, 4, 6, 8. Let's find out. Uh-oh. I do get 2, 4, 6, 8. Oh, that's right. N was 8. That's the size of the weird array, right? 1 through 8. Only evens should only be 4, right? So I shouldn't have done that. I should have only gone up to 4, except that that's only because I know exactly what my input is. Who should be responsible for telling me how big the result is? Should it be, there are only two responsible parties here. The main, in other words, you're responsible, or should it be the function that actually creates this thing? So I'll take the responsibility of the function here, right? You give me an array, I create a new array that contains only evens, and I say, here you go, right? I'm giving you the array. If the responsibility was yours to determine how big that array was, right, then you're doing half the work already, right? You're doing this work right here. Find out how big the result should be. Right? That doesn't sound right, right? That doesn't sound like you should be responsible for, you're the main now, that you should be responsible for half that work. I'll do the other half. I should be doing everything. Right? Now the problem is, I need to give you the result of the array, and also, I now need to tell you how big it is. I need to return two things, right? Can I return two things? Not as a return value. So if I need to give you more information, what do I need to do? How do I return 4 CMYK values? How do I return 3 RGB values? By using pass by reference, int result, a size of result. Right? Except that, is that a return value? Nope, that's a pass by value. Pass by reference would be a pointer. Okay? Down here, what I would need is int size of, size of evens. Right? I'll put that above here. And I need to pass that now to only evens. Is that the correct way of doing it? Nope. Only a size of evens is a regular old integer. It expects a pointer to an integer. How do I take a regular old integer, regular old variable, and transform it into a pointer? Star or ampersand? Which one was it? Think scanf. Ampersand. There we go. All right. Then what do I do with it up here? Well, once I've found out how big it should be, what should I do? Size of result is equal to count. Right. Now, you could say, well, okay, you don't need this count variable anymore. You could just go size of, in fact, here, before we do that, let me point out what I was going to do first. Is this correct? It's a pointer variable. How do I take a pointer variable and make it into a regular old variable so I can assign its value? It's just the opposite, star. Now, you could say, well, you don't need that count variable anymore. You could just go size of result plus plus. That ain't going to work. Right? That ain't going to work because of the order of operations. PEMDAS, right? Star and plus plus are two operations. Which one gets evaluated first? What do you think? Plus plus. This is a memory location. If it's at memory location 542, what did you just do? You changed the pointer so now it points to 543, 544, 545. You're changing the pointer where it points to. Don't do that. Right? You would have to do something like this instead. Put everything into parentheses, then you can do that. Ugly. Right? Don't do that. Instead, just use regular old variables and only set it once, right? And be done with it. That's the best pattern that I can give you. Right? Question? Or no?
I was going to ask if you could do that.
Yeah, that's the preferred way. Don't go messing with pointers more than you have to, right? Keep things simple. Right? Now down here, what I can do is instead of using 4 now, I can use size of evens, and everything is correct with the world. 2, 4, 6, 8. Nice. If you need to communicate more than one thing from your function that's screaming out to you, use pass by reference. Right? No other questions online? Any questions here? No, then the plan for the rest of the week is to finish up with arrays on Wednesday. Do a demonstration of arrays using GDB, which is a debugger, because you'll use that after we come back from the break. The midterm is next Wednesday, not this Wednesday, the Wednesday after we come back from break, and it's probably going to be the same format as the other exam. Whether or not we have class on that Wednesday, if we have class, I'll just treat it as a review, and it's optional. You can come. You can. We'll do an old midterm during the midterm because I'll give you that regular time. Otherwise, if you don't want to and you want to use that 1 hour to actually do the midterm, that's your business. You'll have until what was it? What did we do last time? Midnight? Or okay, we'll do midnight again. Right. All right. Any questions? All right, then I'll see you on Wednesday.